Hi. In this video, we are going to look at a problem on circles and understand the techniques that we sometimes use when we have circles and tangents and situations like that. So let's look at the question. The circle S touches the sides, touches the side AB and AD of rectangle ABCD and cuts side DC at point F and side BC at point E. If AB is equal to 32, AD is equal to 40, BE is equal to 1, then we have to find, first of all, radius of the circle. Secondly, area of trapezium AFCB. And thirdly, the angle between the pair of tangents from D to the circle. Okay, so that is the problem. Let's try to understand what is happening here. We have a rectangle, something like this, and the circle touches the side AB and AD. So let's label it A, B, C, and D. So circle is touching AB and AD, and it is cutting the DC side and BC side at 2 points. So we can draw a rough diagram like this, touches these, and it cuts. This is my circle roughly. These are the points of contact. These are the points where it cuts the DC side at F, and this is the point E, right? So this is the situation. Your AB length is 32, AD length is 40, and BE length is equal to 1, right? And now we have to find things like radius of the circle and so on, right? So let's try to analyze this situation. You should realize that A is a point from which two tangents are being drawn to the circle. So this length will be equal to this length. And since you can draw perpendicular at the point of tangency and it should pass through the center of the circle should be somewhere here, right? Because the point of intersection of two perpendiculars will be the center. So this point, if you call this distance as r and this as r, this is the radius, and the coordinate of the center of the circle will be r comma r if you choose a comma a as 0 comma 0, right? So center of the circle will be r comma r and radius of the circle will also be r if my point a is 0 comma 0, right? So let me just work it out in the next screen. I will draw a bigger diagram. This is the situation, and there is a circle touching like this and like this, and this is my F, this is D, this is A, B, C, and this is E. So what I'm saying is center of the circle is somewhere here, and this point is r comma r, this is 0 comma 0. They have given AB length as 32, so this is 32 comma 0. And let's say this is my y-axis, so this is 0 comma 40. And by the way, E point will be 1 comma 32 comma 1, because BE length was given as 1. So 32 comma 1. This is my situation. The circle has coordinate of the circle center is r comma r and the radius is r. So equation of the circle will be x minus r whole square plus y minus r whole square is equal to r square. And simplifying this, it becomes x square plus y square minus 2rx minus 2ry. There is a plus 2r square minus r square. So plus r square equals 0, right? This is my circle equation. And I know that E is a point on the circle. 32, comma 1 is a point on the circle. So let's use that to find out the radius of the circle. So we'll put 32 square plus 1 minus 64r minus 2r plus r square is equal to 0. And this equation becomes r square minus 66r plus 32 square is 1024. So 1025 equals 0. And this can be factorized. It is r minus 25 and r minus 41. So the radius of the circle can be 25 or 41. Obviously, since the radius is smaller than the length of this side, we have to reject the 41 answer. So radius of the circle is 25, right? So that is the first part of the problem. We have found the radius of the circle. Now let's think about the angle between the tangents, pair of tangents from D to the circle. So from D, you can see this is a tangent. We can draw another tangent like this, right? We have to find the total angle here, right? Okay. Now, this total angle will be 2 theta if you call this part of it as theta, right? Not this part of it. I'll just show you in a figure. So you have this line and you have a circle that touches. Let's say this is the point D. From here, we draw a tangent like this. Center of the circle is 25, 25 because we found R to be 25, right? This is A and this point is 0, 0 and this point is 0, 40. Now we have to find the angle between the pair of tangents. So if you join the line from the center to this point here, this angle is theta and this angle is theta. That is what I mean. Now, if I drop a perpendicular like this is 90 degrees. So you should realize that this is 25, right? And we know that this distance is also 25 because this was also a tangent, right? So if this is 25, this much is 15 because the overall length of this side AD was 40. So we have 15 here, 25 here. So we can find this theta very easily. Tan theta is coming out to be 25 by 15 is equal to 5 by 3, right? The same angle is here also. You have to find out double of this theta angle. Theta is equal to tan inverse 5 by 3 and we have to find 2 theta. So 2 theta, notice that this angle is already greater than 45 degrees. So this 2 theta is greater than 90 degree. So you have to do 2 tan inverse 5 by 3. And according to inverse trigonometry, when the angle exceeds, when this quantity x is greater than 1, it will be pi minus tan inverse 2 into 5 by 3 by 1 minus 25 by 9, right? So that will become 10 by 3 by pi minus tan inverse 10 by 3 and 1 minus 25 by 9 will be basically 16 by 9. So 16 by 9. And I have taken the minus sign outside. So this becomes basically 3, 15 by 8. So you will get pi minus tan inverse 15 by 8. That becomes your required angle. You are doubling this angle. You should check this is the same thing as this. Pi minus tan inverse 15 by 8. That is my required angle between the pair of tangents, right? Now, the next part of the problem is about finding the area of trapezium AFCB. So again, let's think of the figure once. You have a circle like this. This is C, this is F, this is D, A, B, E, right? So we know that this point is 0, 40. This is 0, 0. This point is basically 32, 40. This point is 32, 1. We have to find basically this F point. Unless we find F, we cannot find area of the trapezium AFCB, right? So how do I find this F point? So F point is the point where the line CD cuts the circle. Line CD cuts the circle at F, right? Now what is this line CD? Line CD equation is y is equal to 40 and the circle equation is x square plus y square minus 50x minus 50y plus 625 is equal to 0. Because you recall the radius of the circle was 25 and the circle center was also 25, 25, right? This was the equation of the circle. Now using this CD, y is equal to 40 line equation, we can put it here in this and you'll be able to solve for the point of intersection of the line and the circle. So you will get x squared plus 1600 minus 50x minus, this is 50 into 42,000 plus 625 is equal to 0. And you will get x squared minus 50x and this will come plus 225 is equal to 0, right? So we get this equation. Now think about it. If you solve it using the quadratic formula, it is 50 plus minus root over 50 square 2500 minus 4 times 225, so 900 by 2. So x is becoming 50 plus minus, this is 40 by 2. So it is equal to either 45 or is equal to 5. Now this point F cannot be at x is equal to 45. That is clearly inside the side CD. So this point must be at 5, 40, right? We have to reject the 45 answer to find F. So if this is at 5, 40, this length DF is 5 units. So CF length is becoming 32 minus 5, 27 units, right? And now we have to do the area of the trapezium. The opposite sides have length 32 and 27. And the height or the distance between the parallel lines is equal to 40. So area of the trapezium is half into 40 into 32 plus 27. So this is 20 into 59 and this is 1180. So that is the required answer. And again, we are using the line equation and the circle equation to find the point F. So that finishes off all three parts of the problem. Hopefully you've understood the logic by which we use the tangency condition to find the information that we needed, right? So that's it for this one. I'll see you next time.